Good morning. Today I'm going to look at Eastern Cape, Geography Paper 1, September 2023, Grade 12. I'll be focusing on Section A, question 1.1 up to 1.5. I'll be focusing on Section A, question 1.1 to 1.5. That's going to be my main focus. So let's go through the paper. Okay, so climate and weather and geomorphology, but the main focus is on climate and weather. I'll try to add one or two things just to simplify the things. Okay, various options are provided as possible answers to the following questions. Choose the answer and write only the letter A to D next to the question numbers 1.1.1 to 1.1.8 in the answer book, for example 1.1.9D. A zone of constant pressure between two cyclones or anticyclones is known as. We have got options that are given. We have got a ridge, then we have got a trough, we have got a front, then we have got a saddle. So from the options that we are given, let's try to use elimination so that we are left with the correct answer. What does a front do? It separates cold and warm air. Think about what happens within the subpolar. Within the subpolar, we have got cold air that is coming from them, polar high. Then we have got warm air that is coming from the subtropical high. What separates those two is a front that is found at the subpolar low pressure. So a front, what it does is a boundary or a line that separates two air masses of different characteristics. When we're looking at air masses with different characteristics, we are looking at them in terms of temperature, in terms of moisture content. So if you look at what is coming from the subtropical high, it's warm. What is coming from the polar high is cold. So if you compare those two, you find out that they are not the same. They are separated by a front. Okay. And then a ridge is an elongated area of relatively high pressure. So when you talk about the ridge, we are talking about the elongated area of relatively high pressure. When you talk about a trough, we are talking about an elongated area of low pressure. So this is an elongated area of high pressure. This is an elongated area of low pressure. That's what a trough is. So the saddle now, we have high pressure here, okay? We also have high pressure on the other side. So what is in between is what we refer to as the saddle. So your answer there is D. Then northeasterly wind of 20 knots is evident in, if you look at what the options that we are given here, this is something to do with the weather station models. Okay, so let's try to eliminate the answers that are not correct. This one you can see it's 15, 10 and 5. These are the notes that you're seeing here is 10 and 5. Okay, you can also see this one is what is 10 and 5, which is 15. This is 15 as well. So this is northeast, this is southwest, this also is southeast. So the only correct answer is, you've got here is northwest, northwesterly wind. This coming from the west blowing towards this direction. Then you've got these two which shows 20 knots. So your answer there will be A. Okay, anticyclones are associated with that is number your number 1.1.3. Anticyclones are associated with, of course, what we have. Anticyclone, we need to know what an anticyclone is. An anticyclone is a high pressure system. I'll say HP. It's a high pressure system. What is it associated with? Okay, anticyclones are associated with, okay, we are going to come up with the answer now. What is it associated with? It is associated with cold weather, cold air. And what are some of the characteristics of the cold air? Cold air is heavy. What does it do? It sinks, okay, or it subsides. Okay, so cold air is heavy, it's denser, it sinks, it subsides, and in most cases we are likely to have calm and clear weather conditions. Calm and clear weather conditions because the air is cold and dry. It's heavy, it subsides, You are likely to have calm and clear weather conditions. So from the options that we are likely to have stable weather conditions. Okay, that is stable weather conditions. So also looking at what happens within the subtropical high in the upper atmosphere, what happens, there is divergence that is taking place, which means they are moving away from each other. So the answer then is divergence, because where we have got warm air, what happens? Warm air is light. Number one, what does it do? It cools, it condenses, clouds form, then we have got precipitation. That is the difference. Now warm air is light, it cools, it continues rising, it condenses, clouds form, then we've got precipitation. Okay, so this is a cyclone. When you talk about warm air, we are talking about a cyclone. Okay, when you talk about cold air, I just want to add something that I have here. So when you talk about cold air, this is basically what we are saying. So if you check the two, what do we have? This is high pressure. What happens within the high pressure system or anticyclone? The air is cold, so as a result it subsides. But as it is subsiding, it is warmed adiabatically, because within in height the temperature increases. That's what we are trying to say. As it is going down, it's warmed up adiabatically. So it means it's cold, then as it is sinking, it's warmed up adiabatically. But when you look at your law now, you can see that it's warm air. What is happening? It's cold. Warm air, as it rises, it cools, condensation takes place, then we have got clouds that form. Okay, this is the same thing that we're talking about. Of course, when we talk about high and anticyclone, this is an example of an anticyclone. This is an example of an anticyclone. This is an example of a cyclone. Okay, high pressure and low pressure center with wind direction northern hemisphere, circles isobars with pressure in millibars or hectopascals. So this is what you can see here. You can see here is an anticyclone, but this is the northern hemisphere, that's why it's clockwise. This is a cyclone, it's in the northern hemisphere, that's why it's anti-clockwise. So this is how an anticyclone look like. You can see high pressure at the center, but as you go outwards, the pressure is increasing. There's a isobaric interval of 4 millibars or 4 hectopascals. Same applies here. You can see there's low pressure, the pressure increases as you go outwards. So this low pressure is associated with warm air. Warm air, what it does is it's warm, it's light, so it forced to rise. As it rises, condensation takes place. And condensation takes place, clouds form, then resulting in precipitation, rainfall. This one is cold. Cold air, what does it do? It descends because it's heavy, it's denser. Cold air does not hold any moisture, but as it is descending or subsiding, it means now it's going to be warmed up adiabatically. The temperature increase with a decrease in height. Why? Because it is warmed up adiabatically. So that's something that can aid to the question so that you have a better understanding. So it's stable and divergence. That's the correct answer. Okay. Also to add to that, this is an example of a low pressure. You can see what happens within the low pressure. Warm moist air rises and cools down. Warm air rises and cools down, and what we have after it has risen and cooled down, we now have clouds forming and we have rainfall. Then cold air, what does it do? Wind blow in the clockwise direction. Of course, this is within the northern hemisphere. Okay, high pressure, dry and cold air declines and warms up. It is warmed up adiabatically. That's basically what I was trying to say, that this is associated with cold air, but cold air is denser. What does it do? It sinks, it subsides. As it is subsiding, it is warmed up adiabatically, which means with a decline of 100 meters in height, there's an increase of temperature by 1 degree. Here, with an increase in height by 100 meters, there's a decline in temperature by 1 degree. Okay, there's a decrease in temperature by 1 degree. That's basically, this is adiabatic. Okay, warming, adiabatic, cooling, adiabatic, warming, adiabatic, cooling. That's basically what we are talking about. Okay, let's move on to the next question. 1.1.4, it reads, backwinds occur when there's dash high pressure and a low pressure cell. Remember, what this usually happens during winter. What is the situation like in winter? Assuming that this is okay, this is where we have got our Kalahari high, this is where we have got our South Atlantic high, then we have our South Indian high. Then here at the coast, what we have got a coastal low. Okay, let's put it that way. So what happens in winter is there's too much subsidence in the interior, such that no air is allowed to go above the invasion layer or the escarpment. So there's too much subsidence here. So as a result, there is no cloud formation, there's no condensation, there's no precipitation in the interior. So we want to be relevant to the question, what is the requirements? Back winds, of course, what we have, it's supposed to be a Kalahari high in the interior, which means 1 here we take 1. What else do we have? There's supposed to be a coastal low at the coast. Supposed to be a coastal low at the coast. So we've got high pressure and low pressure. What happens is wind move from high pressure to low pressure. So we've got high pressure in the interior, then you've got low pressure at the coast. Okay, remember this wind is blowing from the interior towards the coast. It's down a mountain. That's what they're called park winds. Park means a mountain in Afrikaans. So what is happening is as it is descending the mountain, it's warmed up adiabatically. It's warm and dry. Remember the air masses, when we did air mass in grade 12, air mass is a large body of air with similar characteristics in terms of moisture content and temperature. So this is coming from inland or from the interior where it's warm and dry. Okay, it's during the winter, of course, but as it is going down the mountain, it's warmed up adiabatically, which means that makes it warm and dry. But as it gets to the coastal low, we call it an offshore wind. Why? Because it's coming from the land where there's no moisture. It's an offshore, it's warm and dry. On this side, it's coming as an offshore wind. That's why we have all those problems that we have, like the failed fires and things like that, because then when it gets to the coast, it's very hot. Okay, but as it is moving, okay, remember, in the clockwise, as it goes on the other side, becomes onshore. Why? Because now blowing from sea to land. Yeah, it's blowing from land to sea, but now it's from sea to land. It's now in onshore because it has absorbed some moisture now. Now it's warm and moist, which means we're likely to have rain on this side, whereas this side we are not going to have anything. Why? Because they are different conditions that prevails here and also the conditions that we have here. Here is coming from the land as warm and dry. Here is going from the sea towards the land as warm and moist. So we are likely to have rainfall here. So the answer there is Kalahari and coastal. Then 1.1.5, the high temperatures associated with back winds are associated by and the dry conditions due to air movement from, of course. So what is happening? This is the same thing that I was explaining. So number one is adiabatically warmed, okay? Then the other thing is blowing from the land to sea. Because from the land is very warm and dry. But as it blows from the sea to land, it's now warm and moist. So what is happening as far as back winds are concerned? We are saying now when it's going down the mountain, it's warmed up adiabatically, which means the temperature here, they are very high, it's warm and dry, okay? So it's adiabatically warmed, okay? Adiabatic heating, what we call the dry adiabatic lapse rate. But when now is coming here, it's coming from the land to the sea. So your answer there is, which means your answer there is A. Your answer here, Kalahari and coastal, which is 1 and 4. So your answer here is B. Then the high moisture content responsible for the formation of line of thunderstorms is provided by the winds. Okay, when you talk about the line of thunderstorms, I'm going to demonstrate with the diagram as well. We have got South Atlantic high. We have got the South Indian high. Obviously, this happens in summer. Okay, when you talk about the line of thunderstorms, this happens in summer. So obviously, we expect to see L, which is a low pressure. So what happens is we have got our South Indian, Atlantic high, South Indian high. Remember the southern hemisphere, so it's in an anti-clockwise. So it's moving like this. Then same applies with our South Indian. It's an anti-clockwise. It's moving like this. So they meet in the interior. They are separated by what? By the moisture front. So what happens is this one is northeasterly coming from the South Indian. This one is southwesterly coming from the South Atlantic high. You see it's an anti-clockwise from the southwest. This one from the northeast. Let's see what is the correct answer. The high pressure responsible for the formation of thunder is provided by them. High moisture content, of course, is the northeasterly, which is your C. Why? Because the South Indian, that's where you're going to have the moist is coming from the northeasterly, north, southwest, east. It's coming from the southeasterly going towards the moisture front, which is in the interior. Then we are likely to have the line of thunderstorms on our eastern side. Okay, that's what is happening there. Line of thunderstorms are associated with the following weather conditions. Obviously, it can't be this one, it can't be this one as well. That we have got torrential rainfall, we have got heavy rainfall and gust winds. That is the correct answer there. So there is C. Okay, so what is actually happening there? Let me try to just give an explanation. Is we have got the South Atlantic high. we have got the South Indian high. So what happens is we have got the low pressure in the interior. So in summer, all right, let me say summer here. In summer, what is happening in summer is our intertropical convergence zone is now below the equator. It's now below the equator. It has shifted. It's now below the equator, which means now our Kalahari in summer is very weak. Okay, our ITCZ, intertropical convergence zone, it has now shifted, assuming that this is our equator. So it is below the equator. Okay, so our South Atlantic high has moved further south. Our South Indian high has also moved further south, which means in summer the Kalahari is not active. There isn't any subsidence that is taking place. So the wind that is blowing from either of the two, of course from the South Indian, which is moist and warm, is allowed to go above the escarpment. That's what is happening. So when it goes above the escarpment, it's warm and moist. What happens? It cools, condensation takes place, then we have got rainfall, especially on the eastern side. So in the interior where we have got low pressure, we have got what we call the moisture. We have got the moisture front, okay? We have got the moisture front here, MF, okay? So what is happening now is from the South Atlantic high and the South Indian high, all right? So what is happening is, remember in the southern hemisphere, anticyclone, it winds. The wind moves in an anti-clockwise direction. So it means it's moving like this towards the interior where we have got the low pressure. Then towards our South Indian high, it's also moving in an anti-clockwise towards the interior where we have got the low pressure. So they are mating in the interior, but they do not mix because they are air mass with different characteristics in terms of moisture content, in terms of temperature. From the South Atlantic high, this is emanating from a cold ocean. So which means this is cold and dry. Okay? Then from the South Indian high, this is emanating from a warm ocean, which means this is warm and moist. Even if when it starts, it doesn't have a lot of moisture, but it's passing through a warm ocean, which means there's absorption of moisture. As it absorbs moisture, which means it becomes more moist. That's what it's moisture laden. It has got a lot of moisture. It's also warm. So when they meet in the interior, they are separated by a moisture front. I've just said NF. Okay, so when these two air masses are separated by moisture front, what happens? The warm moist air from the South Indian high, which is a northeasterly wind, is undercut by the southwesterly wind from the South Atlantic high, which causes it to rise. As it rises, it cools, condensation takes place. Then we have got clouds of vertical extent like the cumulonimbus clouds. Usually we have got a line of thunderstorms on the eastern side. This is why we have got the line of thunderstorms on the eastern side. Even if you look at the rainfall distribution in South Africa, you'll find that on the western side, there's little or no rainfall, but as you go towards the east, the rainfall amounts increases. More rainfall is received on the eastern side. It is because of the positioning of the high pressure system, that your South Atlantic high and your South Indian high, and also the position of your plateau, which in summer allows the wind to go above the escarpment, which results in condensation, more clouds form. Then we have got rainfall on the eastern side. So we've got the South Atlantic high, which has got the southwest cold and dry winds because it's emanating from a cold ocean. Then you've got the warm and moist from the South Indian high, which is emanating from a warm ocean, which is a northeast wind. So this is warm and moist, separated by a moisture front. So separated by a moisture front, the southwest cold wind undercuts the warm air, causing it to rise. As it rises, clouds form, condensation takes place. We have rainfall on the eastern side. We have a line of thunderstorms. So that's what happened there. Okay, let's move on to the next one. Then the coastal low on the map below will be first move in a direction or in a direction. Okay, let's see what happens in 1.1.8. Okay, so we are saying now it moves in an easterly direction. Okay, and it also northeasterly direction, because you remember our coastal low, it moves along the coast. It moves along the coast. So the correct answer is the easterly and the northeasterly. That is the correct answer, which is D. Okay, let's move on to the next one. All right. So the following questions are based on local climate. When you talk about local climate, you need to be aware that these are microclimates. We are looking at why is it the area of a certain area, the climate of a certain area is different from the surrounding areas. That's basically what we are more concerned with about. Okay, local climate, that is your urban climate, and that is your valley climates as well. That's basically what we are talking about. Choose the correct ways from those given in brackets. Write only the words next to the numbers 1.2.1, 1.2.7. So refer to the sketch below in question 1.2.1 and 1.2.4. So what is happening now, it has already been highlighted that is during the night. So what we are going to do, what I'm going to explain just to make it easier is during the night, what are we likely to have? We are likely to have cold air, okay? Cold air, what does it do? Remember from our explanation, cold air is heavy, okay? Cold air is more denser, so it sinks. So when you're looking at our valley now, we are looking at the arrows that are pointing downwards, which shows that it's cold air that is subsiding, okay? Cold air that is subsiding or that is sinking because it's heavy. How you get them? Number one. Number two, you can also see there's a frost pocket here, which usually takes place when the temperatures below the valley is below the freezing point. That's when we can have our frost pocket. Then the other thing, our invasion layer. Obviously, our invasion layer, we are saying now, this is a warm air that is trapped between two parts of cold air at the top and also at the bottom. That's how we end up with the invasion layer, or what you call the thermal belt. Okay, this is warm air that is trapped between two parts of cold air at the top and cold air at the bottom. So as the cold air is descending, whatever is warm at the bottom of the valley is forced to rise because it is light. So that warm air is replaced by the cold air at the bottom. Then at the top already there is cold. So this warm air is trapped between two parcels of cold air. There is cold air here, there is cold air here. That's how we end up with the thermal belt, or what we call inversion. Okay, but when you're talking about temperature inversion in general, this is an increase of temperature with an increase in height. That's what temperature inversion is all about. Okay, so the wind in this case is obviously it's during the night. That makes it what? Katabatic. Okay, then 1.2.2, the answer there is B. The reason being that when we talk about aspect now, what happens in the southern hemisphere? North-facing slope are warmer than the south-facing slope. As a result, you can see, that's why we are saying it's B there. Then we are looking here, planted in the valley floor, where we have got the frost pocket. Temperatures are going below 0 degrees. Of course, frost-resistant crops from the options given as a citrus crop, we can go off for oranges then. The invasion layer developed due to the displacement of, obviously, it's of warm air. Because warm air has been displayed from the bottom of the valley. It has risen. Why? Because it is light. It has risen because it is light. That's the air that has been displaced. So as a result, we have got cold air at the bottom and cold air at the top. Then we have got warm air trapped in between two parcels of cold air. Okay. Refer to the photograph below based on the urban climate to answer the questions. Of course, the start of climate city is known as, obviously, we are looking at urban climate that is called micro. Why the urban areas climate temperatures are higher, of course, than the surrounding rural areas. We are studying the city, which means we are focusing on why is it different from surrounding areas, micro, in a smaller scale. That's micro climate. Okay, so when there's an accumulation of soot, okay, there's a accumulation of a layer of pollution over the urban area, that becomes your pollution dome. Okay. Artificial surfaces, urban activities is the factor that contributes to higher temperatures over the city in the photogram. Obviously, these are the artificial surfaces. What do we have in the urban areas that helps in making sure that the temperatures within the urban areas are higher than the surrounding rural areas? Obviously, the artificial surfaces, we're talking about your concrete surfaces, anything that is within the urban area that absorbs, that results in the weather that is within the urban area to be different from the surrounding rural areas. Okay, it's mostly it's artificial surfaces. Okay, then 1.3, refer to infographic below on mid-latitude cyclone. Okay, when it comes to mid-latitude cyclone, what you need to know is when you talk about mid-latitude cyclone, let me just draw something here. Okay, this is more like your global air circulation. This is your low, this is your high, this is your low, this is your high, this is your low, this is your high. I'm just going to demonstrate so that at least you have an understanding. So this is your equatorial low. I'll say equatorial low. This is your subtropical high. Okay, this is your subpolar low. This is your polar high. Okay, subtropical high. Okay, this is your subpolar low. Okay, this is your polar high. So we have got the pressure belts that we have got this one at 0 degrees equatorial low. Then at 30 degrees north and south, we have got the subtropical high. Then at 60 degrees north and south, we have got the subpolar low. Then at 90 degrees north and south, we have got the polar high. So once we know about this pressure belt, then it becomes easier because this is where the mid-latitudes, the tropical cyclone, subtropical anticyclone is derived from. So the first thing is within the tropics, that is from 0 to 30 degrees north and south, we have got the tropical easterlies, the trade winds, tropical easterlies. So whatever happens within this latitude is driven by the easterlies. That is from 0 to 30. We have got the tropical easterlies, okay, from 0 to 30 degrees. Then from 30 to 60, we have got the tropical westerlies. We have got the westerlies, tropical westerlies, call them tropical westerlies. Then tropical westerlies. Then from 60 degrees to 90, we have got the polar easterlies. We have got the polar what? Easterlies. Okay, that's what we have. So what is happening now when you talk about mid-latitude, it's within the 30 to 60. That's where it's taking place, which means it's mostly driven by the westerlies. It's between 30 to 60 north and south. Well, let's go to our infographic. Direction of movement. You can see where the arrow is pointing at. It tells you that it's moving from west to east. Okay, this is exactly what I was talking about. It's moving from west to east because it's driven by the westerlies. Okay, what else do we have? We have got a cold front here. Behind the cold front, these are the basics. Behind the cold front, there's cold air. Ahead of the cold front, there's warm air, which is the warm sector. Okay, behind the cold front, there's cold air, which means here there is steeper pressure gradient. Okay, let me just talk, then I'll take when I get to this diagram. Okay, behind the cold front, there's cold air. Ahead of the cold front, there's warm air. So when you look at these two, the reason why we have got the cumulonimbus clouds here is because there's steeper pressure gradient, which means the cold air behind the cold front causes massive upliftment of the warm air. As it is uplifted, it means condensation takes place, clouds form, then you've got clouds of vertical extent like the cumulonimbus, which is formed. So that's why we have got rainfall here, where we have got the position of our cold front. But when you look at where we have got our warm front here, you can see what we have. We have got cool air, okay, which means here there's gentle pressure gradient. You understand? That's why we end up having moderate to light showers as compared to here where we have got heavy rainfall, because here there's massive upliftment of warm air, which causes condensation to take place, clouds form, then we have got heavy rainfall. So that is the difference between the two. But this is basic principle that I want you to know. Behind a cold front, there's cold air. Behind a warm front, there's warm air. Okay, you should know the positioning. Where is your cold front? Where is your warm air? That's what you need to know. Where is your cold front? Where is your warm air? You should know the positioning of cold air and warm air between the cold front and the warm front as well. Okay, so what we have, let's go to the next one, synoptic weather map. Okay, from what you are seeing, you can see here the isobars, which shows the area with the equal pressure. Okay, the same equal pressure. Okay, isobars, they are very close to each other, which denotes or which shows steeper pressure gradient, which means there is strong wind behind the cold front. That's why now we have got now at some point the cold and the warm. The cold catches up with the warm front. That's how it becomes occluded. When you're talking about the occlusion, we're talking about the merging of the cold and the warm front. They are now merged. Why? Because there are strong winds behind a cold front, which causes the cold front to catch up with the warm front. That's what we mean when you talk about the occlusion. You can see at the apex here is the warm occlusion. Why? Because at the apex you can see the symbol of a warm front. Okay, so now we have got, now it has merged. Of course, one can suggest that this is a mature stage where there is a defined cold front and defined warm front, which means you can see them clearly that this is a cold front and this is a warm front. That's what makes it more of a mature stage. Let's read what we have. Cape Town, torrential rains and flooding have damaged thousands of informal structures in and around Cape Town. So you can see that our cold front is associated with the heavy rainfall, floods to be specific, which have got negative impacts on the environment and also on society. Disaster risk management said on Friday the city's metropole was struck by heavy rains, gale winds, high seas, plummeting, dropping temperatures this week because the cold front is approaching, obviously the temperature will drop. On Wednesday, the city saw flooding in former settlements and rose with rain and thunder. Heavy snowfall recorded in northern and Overberg regions of Western Cape. DRM spokesperson Charlotte Powell said the rains caused substantial flooding in former settlements across the city. Okay, so here what is trying to bring out is some of the impacts of mid-latitude cyclones. Obviously, they are associated with floods. So what usually happens when it comes to geography is we explore a phenomena or concept. We look at how it takes place, number one. What are the problems that emanate from the concept that we have explored, and what are some of the strategies that we can put across to make sure that we counter some of the problems or the impacts. That's the approach. So it's explanation of the concept. What is the problem? What are the solutions? We don't just only explain the concept. We don't just only identify the problem, but we are also supposed to come up with the solutions to the problems. Okay, according to the infographic, in which direction does the mid-latitude cyclone move? Remember, I showed you through this diagram that is driven by the westerlies. So it moved from west to east. So you can see the direction of movement there. It moved from west to east. You can see easterly. That's what we mean. 1.3.2. Why do cumulonimbus clouds develop ahead of the cold front? So we are saying now warm air rises sharply along the steep cold front, intense uplift of the air along the cold front. So what is simply happening is when you look at your cold front, there's steeper pressure gradient here. So there's massive upliftment of the warm air that is ahead of the cold front. As it is uplifted, it cools, it condenses, clouds form of vertical extent like cumulonimbus. Then we have got rainfall. That's what is happening there. Then 1.3.3, why does the type of rainfall at B differ from the rainfall at A? 1.3.3, what we are simply saying is there's a gentle gradient here. You can see the isobars are further apart. There's gentle gradient at B that results in the formation of stratus clouds and hence lighter rainfall. But when you look here where you've got your cold front, cumulonimbus clouds causes heavy rainfall because they have rainfall. Why? Because of the steeper pressure gradient that we have there. Then stratus clouds cause soft, penetrating light rainfall. So that's what is happening. Here there's massive upliftment because of the strong winds, the steeper pressure gradient. Here there's gentle pressure gradient, hence we have got light rainfall here. Then here we have got heavy rainfall. Cumulonimbus clouds, heavy rainfall, stratus clouds, light rainfall. That's what is happening. 1.3.4. Give evidence that the warm front occlusion developed. This what a warm front symbol at the apex. If you can check here, you can see here the apex. You can see that is the warm front. That's what makes it a warm front occlusion. Okay, so if this touches the surfaces, what is on the surface is what determines whether it's a cold front occlusion or it's a warm front occlusion. So you can see the symbol of the warm front. It's a warm front occlusion. Okay. Then moving on to the next one, 1.3.5. How did the warm front occlusion develop? Okay, the coldest air is found ahead of the warm front, and the cold air is undercut along the warm front. That's basically what is happening. So when it comes now, let me try just to when it comes, let me try to explain it like this. Okay, this is your cold, this is your, so we are saying now the positioning now, when it's cold front occlusion, there is cold here. Then here there is what? Cool. Then here there is warm. Okay. This is your cold front occlusion. Okay. Position of cold air, cool air, and warm air. When it's warm front now, it's different. This is your warm front. This is, okay, your cold front. So we are now saying now, the difference now here is cold. Okay, here is cool. Okay, there is your warm. There is your warm. That is the difference, of course. Okay, so that is your difference. So in terms of coldness, this is more colder than what is behind the cold front. When it's a warm occlusion, when it's a warm front occlusion, the positioning now, this one is touching the surfaces. You can see this is your warm front. This is colder than what is behind the cold front. That's what gives you a warm occlusion here. This one gives you a cold occlusion. There's cold, warm, cool. So you have to know the positioning now of your cold, warm, and cool. The warm will always be the warm sector, doesn't change its position. What is only changing its position is the warm front touching the surface. That is a warm occlusion, warm front occlusion. That is a warm front occlusion, which means the warm front is touching the surface. Then you've got cold. This one is cool. okay? Cold, this one becomes cool, then you've got a warm front. Here, if it's a cold front occlusion, which means your cold front is touching the surface, we have got cold, warm, and cool. So it's just a matter of just shifting the position. You need to know where is your warm, where is your cold, where is your cool. When it comes to warm front occlusion, we have got the warm front touching the surface, the cold, okay, ahead of the warm front. That's basically what you're saying. The cold SA is found ahead of the warm front. It's ahead of the warm front, the cold A here. Then we have got the cool air here behind the cold front. That is your warm front occlusion. When it's a cold front occlusion, which means you have got your cold is touching the surface, there's cold behind the cold front. Then warm sector remains where it is. Then ahead of the warm front, we have got the cool. That is the difference between a warm occlusion and a cold front occlusion. Cold front occlusion, positioning cold behind the cold front warm, then ahead of the warm front is cool. That is a cold front occlusion. Then for a warm front occlusion, behind the cold front there is cool air. Ahead of the warm front there is cold air, but our warm air remains where it is. So that is a warm front occlusion. This is a cold front occlusion. Let me say it again, because this one usually confuses a lot of learners. Let me try to do it on a separate paper. So what we are saying is, this is your warm front occlusion. Okay, cold front. Okay, sorry. Cold front occlusion. What happens? This is your cold front. So here there is cold air. Here there is cool air. Here obviously warm air, warm air, okay, warm air. Sorry about my handwriting. So there's warm air, there's cool air, there's cold air. This is a cold front occlusion. What is happening? Our cold front is touching the surface. Okay, so when it comes now to the warm front occlusion, we are saying now this is our warm front, this is our cold front. Here is cold air. Here is what? Cool air. But here is what? Warm air. Okay, that's basically what is happening. So this is a warm front occlusion. Okay, so what is happening? The difference now is in a warm front occlusion, the warm front touches the surface, then ahead of the warm front there's cold air. Behind the cold front there's cool air, then we've got warm air. So you need to know the position of the warm and cold air. This is your warm front occlusion. Then here, cold front touching the surface. What do we have? You've got your cool air ahead of the warm front. Then you've got cold air behind them, cold front. Then you've got your warm air. Okay, there, where it's supposed to be, where the warm sector is. So this is your cold front occlusion, this is a warm front occlusion. To repeat again, because I know this confuses a lot of learners. Okay, cold front touch the surface. Behind the cold front there's cold air. Between there's warm air, warm sector. Then we have got now ahead of our warm front there's cool air. This is your cold front occlusion. Then under your warm front occlusion, the warm front is touching the surface. Ahead of the warm front, there's cold air. Behind the cold front, there's cool air. Then we've got the warm air. I've explained enough there. Okay. Then what else do we have? How did I've explained 1.3.5, how it happens. The coldest air is found ahead of the warm front. I've explained that in detail. Refer to the extract. State one element of weather that is associated with cold front according to the extract. Okay, 1.3.6 is rain, obviously. When we talk about the elements of weather, of course, we're talking about precipitation that comes in form of rain. Okay, we're talking about the temperature. Okay, is it cold or warm? And we're talking about the winds in terms of its direction, in terms of whether it's in terms of its speed. So we're talking about temperature, rain, and also the winds. Okay, we can also talk about cloud cover. That's anything, okay, among those four. Those are the four elements of weather. Okay, then explain how the weather conditions associated with the mid-latitudes would negatively impact the residents in the informal settlement. So we are saying now this mid-latitude, they're associated with floods, which and what negative we are now explaining weather conditions associated with the mid-latitude cyclone would negatively impact on the residents in the informal settlement. So the question is asking you to look at the negative impact on the residents of informal settlement. What are we likely to have as the negative impacts on the informal settlement? Okay. So we are saying now, heavy rain would result in flooding of homes. Remember the type of material, the cheap material that is used to build these informal settlements. They are spontaneous and planned settlements. They are not in the plans of the municipality. Some of the time you find that these people are not employed. They find themselves land that is vacant. Then they start building their structures illegally. Okay, they lack the basic services. So now we are looking at heavy rain would result in flooding of the homes. That's number one. Okay. Heavy rain would wash away roads. Usually the roads that you find within the informal settlement, they are not the standard ones which are tarred, which have been prepared, constructed by the municipality, because these structures are illegal. You understand? So heavy rain would wash away roads. Heavy rain will cause informal settlement to become inaccessible or cut off. Why? Because of where they are built. There is no infrastructure that is strong enough. Okay, it makes them inaccessible or remote. Okay, they are cut off because of that. Low temperatures would cause residents to fall ill. Remember, the low temperatures, the material that they use, mostly zinc, those cheap materials, so they are exposed to cold, which makes them ill. Gale force winds would destroy damage in former settlements. But these are some of the things that you can actually talk about. What are the likely structures that we are likely to have in informal settlement? Informal settlement is a spontaneous settlement that is unplanned, that is illegal. It's not in the plans of the municipality. They are there because some of the people are unemployed. They cannot afford accommodation. They end up building houses where there is vacant land. So that's what is happening. So as a result, the structure that they use, they are not strong. So you look at heavy rain, what will it have? What will it do to the homes? This flooding of homes. Heavy rain will wash away roads. Heavy rain would cause informal settlement to become inaccessible, cut off, among other reasons. So these are some of the things that you can actually include. Let's move on to the next one. 1.4. Refer to the sketch below showing the path of the tropical cyclone Freddy. So when you read this already, you know that when it comes to your tropical cyclones, they are named alphabetically. So when you hear the word Freddy, it's suggesting you that it's number. Which number is it in terms of flood? A, B, C, D, E, F, which means it's the sixth cyclone in that season. That's what it means, because they are named alphabetically from A going upwards. Okay, how many tropical cyclones developed during Freddy? So what we are saying now, since we have got F, is before, which means we are saying A, B, C, D, E. So that's 5. That's 5 cyclones that have developed. You have to be attentive to detail, because some of you just write up to F, then you just write 6, but it's before, which means you are not including Freddy. That makes it 5. Then in which country did Fred first make landfall? Okay, if you can check here, let's check our days. Okay, you can see from year 18, 19 is moving. The first one there you can see it's Madagascar. That's when it made the landfall. That's Madagascar. There you can see it's made landfall in Madagascar, which is an island. Okay, give reason for your answer in question 1.4.2. 1.4.3. Fred moves in an easterly direction. You can see it is moving in an easterly direction from yes, moving in an easterly direction. Okay, what do we mean by that? Let me just try to explain. Okay, so I'll just use okay, this is at 0 degrees. Okay, usually within 0 degrees there is no Coriolis force. So we are saying now for our tropical cyclone to start moving, it moving at 5 degrees south or 5 degrees north. So there I'm gonna write, okay, 30 degrees south. Okay, so what it does is it's driven by the easterlies. So it moves from here going, you can see it moves in this direction. Of course, I just want to demonstrate something. Of course, it's going to be different from what we have from our infographic. So it moved from the east, it's driven by the easterlies. The temperature is supposed to be 26.5 degrees and above. It's supposed to be over the warm ocean, so that there's evaporation that takes place, absorption of moisture, there's a release of latent heat, and within the ocean there's no friction. This is what gives energy to the tropical cyclone. These are the conditions that gives energy to the tropical cyclone, is within the warm ocean where evaporation takes place, when evaporation takes place, when more latent heat is released during condensation, this gives more energy to the tropical cyclone. So it's driven by the easterlies and it moves in this direction until it reaches 30 degrees south. So we are next saying it has reached landfall, which means now there's more friction, there's no source of moisture, hence it starts to move in this direction. This is just to explain you in a diagram, okay, just to show you what exactly happened. Let's go back to the question. In which country? We have said Madagascar. Give reason for your answer in question 1.4.3. Okay, we are saying Fred moves in an easterly direction. Fred moves from west to east. Okay, Fred first country, east to west part of Fred. So it's moving from here. This is eastmost. This is east. So it's moving towards this direction. This definitely what I'm talking about. It's moving. This is the first country, okay, on the western side. Of course, that's what we are saying, from east to west part of Fred. That's Madagascar, okay. Then, why did Freddy intensify the 22nd and 23rd? 1.4.4. It reached water after landfall. High temperatures and evaporation energized the system. No more friction over warm waters, increase in latent heat. They are just asking you the conditions that actually favors the intensification, that's intensify a tropical cyclone. We are saying now it reached warm water after landfall, which means in the warm water there's bound to be more evaporation. When evaporation takes place, there's bound to be more condensation. Of course, it gives energy. It's giving energy to the tropical cyclone. High temperatures and evaporation ingest the system. It means the high temperatures 26.5 and above. It's actually resulting more evaporation taking place, which means there's more moisture that is released, and during that process condensation takes place. There's no friction, so which means there's source of moisture, there's a release of latent heat, which makes the tropical cyclone to be more energized or to intensify. That's basically what we're talking about. What are some of the conditions that favors the intensification of the tropical cyclone? We've got your temperatures are high, warm oceans, there's increase in latent heat. It gives energy to the cyclone. Okay, 1.4.5, name X indicated on the satellite image. This is your eye. This is your eye. And what are the conditions that are associated with the eye? Obviously, it's what? Cold air, sinking, calm condition. But as it is descending, it's warmed up adiabatically. There are clear calm conditions within the eye. So you need to be aware of what happens within the eye. Name one weather condition at X, the eye. There are clear skies. Why? Because that air now is descending, it's sinking, it's cold. As it is descending, it's warmed up adiabatically. So they're likely to be high temperatures as well. Little wind, no precipitation. Why? Because the air there is the same as the one that I've explained under anticyclone, that it is cold. When it is cold, what happens is descending. As it is descending, it is warmed up adiabatically. We are talking about what is happening here. This is what happened within the eye. Dry, cold air declines and warms up. It is warming up as it is descending. It's warmed up adiabatically. That's basically what we are talking about. Okay. Then 1.4.7, give a reason for the weather condition mentioned in A. It means now descending air causes clear skies because it's cold and dry. Heating up of descending air causes high temperatures. Weak pressure gradient leads to very little wind. Loss of moisture due to descending air causes no rainfall. As it is descending within the eye, we are saying now it's cold, of course, in the upper atmosphere, but as it is descending now, it's warmed up adiabatically, which means that descending air does not have any moisture with it. As the temperatures are increasing, which means whatever moisture is left within that pass of air is also evaporated. So that's basically what we are doing, what we are trying to say, that descending air causes clear skies. Of course, heating up of descending air causes high temperatures. Waking up, okay, these are some of the things that are, which means it's losing moisture as it is descending. Why? Because the temperature is increasing with a decrease in height. Basically, that's what we're talking about. How will the weather condition at X negatively impact on coastal biodiversity of Mozambique? We are looking at the sandy dunes will be blown away. Remember, we are talking about the coast, okay? Erosion of the coastline will increase. Fauna and flora will be destroyed. Fauna refers to animals, flora to the plants. It will also be destroyed. What else? Habitats and food chains will be disturbed. The salinity of the marine ecosystem will lower. The destruction of infrastructure will pollute the water. So these are some of the things that will take place as far as 1.48 is concerned. Okay, let's move on to the last part. Refer to the factors that influence the weather over South Africa in winter. Okay, here I'm going to explain what happens in winter using the sketch that we have. So this is the sketch that we have. Okay, it denotes or it shows winter, which means when you look at this, it's showing you that your Kalahari a high pressure is very active. That is in winter. You also have your South Atlantic high. You also have your South Indian high. What is the position of this high pressure system? This South Indian high have moved further north in winter. This South Atlantic high is moved further north in winter. Why? Because of the changing of the intertropical convergence zone, because it has moved on top of the equator. That's why you see this one follows it, this one also follows it. But however, in the interior, we have got H, which shows high pressure, which means there's so much subsidence that is taking place. No air that is coming from the South Indian here is forced to go above the escarpment, so that process of condensation and clouds forming and rainfall can take place. So here there are calm and clear conditions in the interior, because there's no rainfall, no precipitation, because there's too much subsidence that is taking place. This is what is happening. The South Atlantic is emanating from a cold ocean, which means the air that is blowing from the South Atlantic high is very cold and dry. The one that is coming from here is warm and moist, but however, is not allowed to go above the escarpment, which means no condensation is taking place, no clouds are formed, no precipitation is also taking place within the interior. That's what is happening because of this. Our Kalahari is very active. This is the position of our Kalahari. Coming to sketch B. This is the same thing that we're talking about. Kalahari high pressure is dominating in the interior, the strong subsidence, which means whatever moist air is coming from the South Indian it cannot go above the escarpment. The moment it can't go above the escarpment, which means there's no condensation that is taking place, there's no cloud formation, there's no precipitation in the interior. And also the presence of the plateau. It's cold here, of course, it cannot go above. There's too much subsidence. So as a result, in winter, we do not have any rainfall in the interior because of too much subsidence of the Kalahari. Okay, because of the so much subsidence of the Kalahari. Let me say it again. So what is happening is the position of our high pressure system. In winter, the Kalahari is very active, there's too much subsidence, no air is allowed to go above the escarpment, which means there's no condensation, means there's no clouds formed, there is no rainfall that is formed within the interior because of the position of our escarpment. Okay, identify the factors in sketch A that influence the weather of South Africa. Obviously, we can talk about the position of our high pressure system, which is the anticyclone. The position, how are they positioned? They moved further north in winter. This one, there's too much subsidence, which means no air is allowed to go above the escarpment. That's basically what you're talking about. The plateau is another reason. Also, the ocean currents is also another reason. We have got the cold, we have got the warm coming thing. So these are some of the factors that actually influence the weather of South Africa. Okay, how would the position of South Atlantic high influence the weather on the west coast of South Africa in winter? 1.5.2. We are saying that the anticyclonic movement will feed the country with cool air. This is coming from a cold ocean, so we are likely to have cool air coming from here, of course, in an anti-clockwise direction. Why? Because there's a cold Benguela current coming from the South Atlantic high. So the Atlantic is a cold ocean, so we are likely to have temperature lower there. So it brings in the cooler air to feed the country. Okay. It would allow mid-latitude cyclone to pass over Cape Town. There will be heavy rainfall, low temperature, strong winds, and low humidity in Cape Town. We are now talking about the position of our cold front. Here, our cold front is passing through Cape Town. Why? Because of the position of our high pressure system. This is moved further north. This one is too much subsidence in the interior. This one is moved further north. So now it allows the cold front to pass through Cape Town. That's basically what we're talking about. Why is the Kalahari high pressure dominant over land in winter? 1.5.3. Obviously, is because of the shifting of our ITC set. Our intertropical convergence zone is in north of the equator. Hence, we have got our Kali high being more active. We have got too much subsidence in the interior. Okay, we can also talk about it is part of the subtropical anticyclone system that changes position with the revolution of the Earth. Obviously, the same thing that I was talking about, that the changing position of our ITCZ is on top of the equator. That's why it's more dominant. There's too much subsidence from the Kalahari then. Weaker convectional currents on the surface that force the descending from the Kalahari high upward. So usually we are just saying in general the shifting of our ITCZ, it has gone over the equator so that there's too much subsidence here. We can also see that with the movement of the ITCZ, our two high pressure systems, South Atlantic high and South Indian high, they also move further north, which means this one now will be more active. Okay. Then 1.5.4, How does the dominant Kalahari high pressure cell influence the pressure of invasion layer in the circuit beam? This is the invasion layer. How does it? There's too much subsidence, which means no air is allowed to go above the escarpment. So there's cold air as well. Then we have got our warm air trapped between two parcels of cold air. What can I add as well? Strong descending air heats up adiabatically down the escarpment, causing high temperatures high up in the atmosphere. There's adiabatic warming or heating that is taking place because of too much subsidence. As it is descending, the temperature increase with a decrease in height. That's what we call the dry adiabatic lap rate. So it increases with a decrease in temperature. Temperature is increasing with a decrease in altitude, height. Okay, so that's why we call the adiabatic dry adiabatic lap rate. Stronger descending air heats up adiabatically down the escarpment. Okay, then in a paragraph of approximately 8 lines, explain how the position in a paragraph of approximately 8 lines, explain how the position of the invasion layer will bring clear and stable weather conditions over the interior of South Africa. Of course, we are saying now there is strong subsidence of air down the plateau, which means no air is allowed to go above the escarpment. As a result, no condensation is taking place, no clouds are formed, no rainfall is received. That's basically what we are saying. There is strong subsidence of air above the plateau. The air heats up adiabatically as it is descending the mountain. The air is adiabatically warmed. That's basically what we are talking about because of the too much subsidence. The invasion layer forms below the plateau, which means since it's forming below the plateau, there is no condensation that is going to take place. There's no cloud that is formed. There's no precipitation as well. Moist air from the warm Mozambican current ridges form from the South Indian high pressure. So we have here when there's elongated high pressure cell. That's basically when we're talking about reaching. Okay, moist air cannot reach the interior of the country because of the position of the invasion layer. There's little cloud formation and hence little rainfall in winter. So all in all, we are saying that our Kalahari high is very active to such a point that no air is allowed to go above the invasion layer. Okay, strong subsidence result in the air going down the mountain to be adiabatically warmed. Okay, the invasion layer forms below the plateau. Moist air from the warm Mozambican current ridges from the South Indian high up the mountain. The moist air cannot reach the interior of the country because of the position of the invasion layer. So all in all, this brings us to an end. But in short, what I want to emphasize is when it comes to climate and weather, boys and girls, our comment, it zeroes on the elements of weather. What will happen to precipitation, that in terms of rainfall, in terms of your snow, hail, etc. So the comment, it hinges on that. What will happen to the elements of weather? Number one, in terms of precipitation, which are various forms of moisture that falls from the sky to the earth. According to the prevailing weather conditions, what will be the situation in as far as precipitation is concerned? That's number one. Number two, we want to know what will happen to the temperature. Is it going to be cold? Is it going to be moderate? Is it going to be hot? So we want to know what will happen according to the prevailing weather conditions that come as a result of a tropical cyclone, that come as a result of a mid-latitude cyclone, or even subtropical anticyclone. The other thing that we want to talk about is the cloud cover. Is it going to be overcast? Is it going to be partly cloud? Are we likely to have clouds form? When we have clouds form, we are likely to have more rainfall. When it's going to be calm and clear, we are likely to have calm and clear conditions, which means we don't receive any rainfall. Is condensation going to take place so that there's build-up of clouds, then we have got rainfall? Then lastly, we are talking about our wind speed. What happens behind the cold front? We have a steeper pressure gradient. Are we likely to have a strong winds? What is going to happen in relation to wind direction? What is going to happen in relation to wind speed? So the other thing that I want to comment on is when it comes to wind direction, it's mostly affected by the Coriolis force, which means how the wind is deflected in the northern hemisphere, deflected to the right, in the southern hemisphere, deflected to the left. Okay, when we talk about pressure gradient now, it has something to do with the wind speed. Are we going to have strong winds, or are we going to have light winds? That has something to do with pressure gradient. Remember, wind moves from high to low. So Coriolis force, it affects wind direction, whereas pressure gradient affects our wind speed. So that's all. Thank you so much for joining me, Weather and Climate, for our paper. That is Eastern Cape 2023. September Geography Paper 1. I hope this will help you in preparation for your Paper 1 that you're writing on the 10th. Thank you so much.